Breaking the Wall of Quark Confinement. Jakub Jankowski, Warsaw University, Poland.
So ever since the ancient Greeks, we have been struggling in a quest to find the most fundamental constituents of matter. So for 2,000 years, we have been smashing, cutting, breaking the stuff around us to see what there are. And in the 20th century, we have come up with the conclusions that there are protons and neutrons which sit inside of an atom. So in the second half of the 20th century, there comes a surprise that protons and neutrons are still made out of tiny little particles called quarks. But now, no matter how violently you collide the protons and the neutrons, you cannot get out a quark out of it. You cannot have a single quark going throughout your detector and observing it. And this is the wall. This is the problem of the question, what is the mysterious force which binds quarks together inside of a proton or a neutron? What's the reason for it? Is it accidental or is it a deep requirement of nature? So when you face this problem, you want to ask yourself a question, what's the other object in the universe which has a similar property? And the answer lies far away in the space. There are the objects called black holes. So the black hole is a strongly gravitational, so it's an compact object which has such a strong gravity that nothing can escape, not even the light, no information. So this bears a direct analogy to the elementary particles I just mentioned, that nothing can escape. And this idea led wise people to a conjecture that perhaps those two effects are just different sides of the same coin, right? You have the very same properties. And this goes under the name of holography. Why? Because if you want to have a look on a black hole which would be somehow describing for you the proton, it has to sit in a spacetime which is of higher dimension, like 5-dimensional spacetime. So in this way, this additional dimension emerges. So this is a very fruitful idea. In the last 20 years, it brought various new results and various new insights. Because you can look also on other quantum systems and ask if they have a kind of gravitational description. Do they also resemble similar properties? So my idea would be to use to the extent possible this description in terms of black holes to get precise quantum notion of what confinement is, besides what I have just shown, to make quantitative statements, and then based on this to develop a road to the solution of the problem and better understanding of the duality I just mentioned. Thank you.
Questions?